Hello, Data Matson here. Today I'm going to run through a little tutorial that I wrote a while back that we ran at the workshop at KubeCon in 2018. And since this tutorial is sort of a timeless piece on how to get introduced to persistent storage with Kubernetes, I thought that I would actually record this and run through it and have you simply learn a little bit about persistent storage with Kubernetes, and let's just dive right into it. And there are some prerequisites here. My environment here, I'm using Vagrant on VMware Fusion on my Mac, and if you don't have Vagrant installed or VMware Fusion running, you can certainly just watch this tutorial as we go through it. This GitHub repository has a long and difficult URL here. I do have a URL shortener for that. I'm going to put that on screen now, and that will be the vanity URL for this tutorial, so to speak. And so let's dive into it here. So you simply need to have a shell, and I'm just going to create a temporary directory here. I'm going to call it demo, and I'm going to cd into that demo directory, and I'm going to clone the repository. Within this repository there is a KubeCon US 18 directory. Let's change directory into that one and simply go through the steps here. There is a Vagrant file here that basically I think you need to edit that to fit your environment. So you need to stick a static IP address on one of the network's interfaces. So in my case here, what I have for the network that I want to use for my virtual network, I believe, is the 192.168.59.1 network. So let me see here. Yes. This has already been pre-configured for my environment. I have my private network set to this IP address, and if you want to change that to something else, you need to change it in the private network IP address, and you also need to change the local listener here, because this is essentially what your Kubernetes cluster will listen to once it has been brought up. And once you've edited that, you simply do a let me check the cheat sheet here. Yeah, you do a Vagrant up, and that will spin up a Ubuntu 18.04 machine with that custom networking configuration that you apply to that machine. And once that is up and booting, a Ansible playbook will install a single node Kubernetes cluster within that virtual machine. There is a let me just show you what that looks like here in the in this directory here. There is a KubeCon YAML file, and you can kind of follow through here what it's actually doing. It installs a bunch of packages. Add kubeadm, install load kernel modules, and so forth. So for the persistent storage backend that we're going to use, we're going to actually use the open source OpenCFS based flex volume plugin we have, which is called Nemo, which is an emulator for Nimble storage. And let me just see what it's doing here. It's installing something else we can watch while this is going on here. The next step here would be to point kubectl to the config file that eventually gets spat out here. Still installing packages. There we go. We need to enable Docker, and then we need to install Kubernetes with the kubeadm. that should go fairly fast as well. So we're also installing the CFS utilities and some other dependencies to be able to run Nemo, because Nemo is using OpenCFS in the background to do a lot of cool things like taking snapshots and clones and things like that. And it's basically 100% compatible with the Nimble storage flex volume driver that we have for HB and Nimble storage. All right, there we go. A few of the post steps here. It configures a network, remove taints on that single master, so we can schedule workloads on it and so forth. And now I simply just want to I want to set the kube config, and I should now be able to do a kubectl get nodes there. Not ready. It should be ready very soon. Let's put a watch on that. All right, it's ready. So the next step would be in the tutorial here is to deploy Nemo, Dory, and company. And if you don't have Vagrant and all the things that I showed you here, there is some steps here on how to install the lab to anything else, basically. So as long as you have Ubuntu 18.04 access through SSH, passwordless sudo access and stuff, things like that, and has Python installed in that VM, then you will be able to run a few steps here to get that configured. But we're going to jump straight to deploying Nemo, Dory, and company. That's basically just two kubectl create commands. We install Nemo as a daemon set, and we deploy Dory as a deployment, and it has a bunch of other RBAC stuff to allow Dory to listen for events on the cluster and so forth. So once that's done, we will now jump to the labs. Another thing that is good to know here that your data is actually stored on the node itself. So what happens is that Nemo, if you don't specify a specific pool to use, it will create a loopback device and map to that, and that will in turn be a file within the virtual machine, and therefore you can kind of reboot this and stuff like that, and your data will persist across reboots. We also have a bunch of different options available for Nemo here. You can watch doing a Docker volume create -d nemo-o help, but you need to do that within the virtual machine itself. So the first step is that we need to create a storage class. The storage classes are in the labs directory within this directory structure, and all the other bits and bobs that we need to use to deploy, right? But I'm going to do this a little bit hackish here. I'm just going to do a kubectl create and simply paste in that. Now we got the storage class deployed. We also need to create a persistent volume claim. We do have an annotation here that we're going to override the description of the volume, because I want to have a custom name on the volume, and that we allow that to do that because we do allow an override in the storage class itself, right? The default description would be volume provisioned from default storage class. All right, so let me just create this 32 gig volume. There we go. We should be able to get the PVC here now, and we can see that it's been bound to a PVC or a PV. Let me show you. There's a PV created there, and now we can use this PVC name to map into a workload. So what we're going to do here is going to deploy a stateful workload referencing a persistent volume claim, and we're going to use MariaDB. There's a very rudimentary script, a standalone pod, so to speak. Normally you would wrap this in a deployment and so forth to provide full HA and things like that. But just to keep it lean and simple, I just have this pod example here. So let's just create that. You can do a watch on the pod here. We should be able to see that it's coming up here. All right, it's up and running. So I have a few scripts here to kind of inspect the workload. What you can do is a df and /var libmysql to show that we have our PV mapped here from tank, Kate's, general, and the UUID. And you can see that this is indeed a 32 gig volume as I requested. And I also have some scripts here to kind of just create some dummy data and so forth. Just paste that in here. It's basically a 2-column database, nothing fancy. Let me see if I can select that data. And there we go. So what we've done right here, just created a PV storage class, created a PVC, which in turn provisioned a PV from the back end, and now we deployed a pod that maps to this PVC. And once we have that PVC within this namespace that I'm currently in, I'm in the default namespace because I haven't configured anything. We're going to do a clone of that persistent volume claim that we just created. So that is also in the repo here. And if you look at the annotations on the persistent volume claim here, we set a custom description, and we also annotated with the dev.hb.com/clone of PVC, and the PVC name, which is MariaDB, right? The storage size I've set to 1 gig here because it doesn't really matter. You need to have a value set there. It will clone whatever size the source or the parent volume is in. So let me just go create that PVC. Now I have two PVCs, and there's MariaDB-clone. It's 1 gig, but it's not truly 1 gig. It's actually 32 gigs because the clone is a 0-copy clone. And then we need to create another pod here, and I'm going to call this pod MariaDB-clone. And it's basically the exact same pod. It's just I've added a few more names here. And the persistent volume claim that we're going to reference is MariaDB-clone. There we go. This pod should already be up and running because the image has already been pulled. So there we go. So now we essentially have a, so yeah, if I would do a df here in the MariaDB clone here, oh wow, that's interesting. It actually says it's 1 gig. So once that's been created, we can then inspect the database that I inserted some dummy data into. You can see that I got my key and my unique value goes here, which was the data that I inserted before, right? And what we can do here is now, just to prove that this is indeed a clone, is that we're going to drop the cloned database. You can see that we're connecting to the clone. We do a MySQL, connect to the KubeCon database, drop database KubeCon. And then we connect to the source database that we cloned from, which is basically intact. and still has the values. So congratulations, you have successfully completed this tutorial, and with that I'm gonna leave it at that. Cleaning up this that I just created, you simply do a Vagrant destroy and your virtual machine will be gone, all your workloads will be gone, and that's it. So that's all for me right now, and until next time, cheers.